Okay, in example number 5, we want to be able to solve an equation containing powers of different bases. So how do we go about this? If we're given an exponential equation in which a common base cannot be found, you're going to solve for the unknown. Number 1, you're going to apply the logarithm of both sides of the equation. Part A, if one of the terms in the equation has base 10, use the common logarithm. B, if none of the terms in the equation has base 10, then you're going to use the natural logarithm. And number 2, you're going to then use the rules of logarithms to solve for the unknown. So in example number 5, we want to be able to solve the equation 5 to the power of x plus 2, which is equal to 4 to the power of x. Now there is no easy way to get the powers to have the same base, because 5 and 4, you're not going to be able to get a same base. But the one thing about logarithms is that whenever you have an exponent that has a variable, then in order to be able to solve for that, you can take the natural log or the common logarithm of both sides. Now since we don't have a base of 10, then we're going to take the natural log of both sides. So just like anything else with an equation, you can add both sides, you can multiply both sides, you can square root both sides, you can also take the natural log of both sides. So here we have the natural log of 5 to the power of x plus 2, and that's equal to the natural log of 4 to the power of x. And then we're going to apply the power rule first. So now we have this x plus 2, we can write that now as a product of this logarithm. So now we have x plus 2 in parentheses times the natural log of 5, and this is equal to the power of x now multiplied by the natural log of 4. And then on the left side, we're going to use the distributive law. So we're going to multiply both the 2 and the x by the natural log of 5. So in step 4, we end up with x times the natural log of 5 plus 2 times the natural log of 5, which is equal to x times the natural log of 4. Now if you look in step 4, we have 3 terms, and 2 of those terms have the variable x in it. So in this next statement, we want to get terms containing x on one side and terms without x on the other. So that means we can subtract x times the natural log of 4 to the left side, and then we can subtract the 2 times the natural log of 5 on the right side. And the reason why we do that is because on the left side, we can factor out an x, so we only have one of them. So since they both have an x in common, in step 6, we have x times the natural log of 5 minus the natural log of 4, which is equal to negative 2 times the natural log of 5. And then at this point, then we can use all the laws of logarithms. So here, since it's subtraction, we can now rewrite this as division. So it's x times the natural log of 5 over 4, which is equal to negative 2 times the natural log of 5. On the left side, we don't change anything in this next step, but over here we can write negative 2 now as the exponent using the laws, or the power rule, to be natural log of 5 and negative 2. The left side still remains the same. On the right side, 5 and negative 2 is the same thing as writing 1 over 5 to the positive 2 exponent. And again, the left side is going to remain the same. And then over here, we know that 5 squared is 25. So this is going to equal the natural log of 1 divided by 25. So now we can divide by the coefficient of x. So in order to get x by itself, we can divide both sides by the natural log of 5/4. And so therefore, this would be the exact solution. Now, it doesn't necessarily mean you have to, do it this way. There's other ways as well. At the very beginning, it's possible that we can just leave this as negative 2 times the natural log of 5, and then in order to solve for x, we're going to divide both sides by the natural log of 5/4. Just depends on how they want the answer. But when you're going through, step 7, it's just practicing using the properties of logarithms, which is really good to practice because the more that you do that, the easier it becomes.